All right, we'll begin on page 8. Welcome back, lesson 11.1, solving linear systems by graphing. So on here it says determine whether the given ordered pair is a solution for a system of equations. Now, in today's lesson, we're going to go over how to graph lines, and they'll either cross at a particular point, they'll either not cross at all because they're parallel, or essentially they're asking us to graph the exact same line. Okay, in this case, because we don't have a picture of these two lines, because these equations are representing lines, we're going to see algebraically if this point is a solution for these two equations. Essentially, if these two lines do indeed cross at this point. So, first thing we're going to do is we're going to take the first equation, and rather than writing x and y, I'm going to leave a space. And I'm going to label also these 2 points, x and y, here. So go ahead and do that now. And instead of writing x and y, we're going to write the numbers instead. Not too bad. The next thing we're going to do is, yes, I drew a line down the equal sign because we're going to see if these two sides, after simplifying each side, are indeed equal to each other or the same. So take a moment right now. What is 2 times -3? That would be about -6. Notice how I brought everything else down. So go ahead and take a moment. -6 plus 8, what would that be? And unpause. Hopefully you wrote 2 equals 2. Now, my question to you is, are both sides equal? Well, yes. Then that means we get to try the next equation, which is highlighted in yellow. So again, I'm going to write down 2x plus y equals 1. Only thing is I'm not going to write the x or y. I'm going to leave a space blank. I'm going to go ahead and, again, draw my line for my equal sign, and I'm going to plug in, instead of x, 2, instead of y, -3. And let's take a moment. What is 2 times 2? That would be about 4. See how I brought down that -3, that equals, and that 1? What would 4 take away 3 be? That would be about 1. Again, I'm going to ask you, are both sides equal? Yes, then that means that this point is a solution. Now, just note that if one of these was not equal, so for example, let's say 2 is equal to 5. Let's say we did all this work and we found it to be 5. Or we did all that work and found that number to be -1 instead of a +1. If that is the case, then that means this point would not be a solution. So just keep that in mind. Also, if I'm going too fast, please feel free to pause so that you can take down some notes. With that being said, just as I kind of previewed on the last slide, we'll be seeing lines that either cross to be one solution, are essentially the exact same equation, even though the equations might look different. They're essentially the same line, which means that there's infinitely many solutions, or the lines don't cross at all and they are parallel. So take a moment right now. How many solutions does a system of 2 equations have if the graphs intersect at one point? They would have one solution, 1 point of intersection. Whereas, let's say, how many solutions would a system have if, let's say, the graphs of the 2 equations intersect at infinitely many points? Well, infinitely many, right? And then, of course, if the lines do not cross or intersect at all, how many solutions would that have? None. All right, so now comes to the point of us actually graphing these lines and seeing if they are indeed one solution, no solution, or many solutions. So let's continue. So first thing we're going to do is we're going to go ahead and graph by finding the x and y intercepts. So here I have the x part of my equation equals the answer part, which is 4. And that one is actually already solved out. Super simple. I love it when that happens because that's always just super simple to do. So on our x-axis, where would 4 be? Okay. Now, as we can see here, to find the y-intercept, our y part is 2y equals, again, our answer of 4. So think about it. 2 times what gets you 4? Or what's the opposite of multiplying by 2? Dividing by 2. So that cancels out. Y is equal to, what is 4 divided by 2? 2. So our y-intercept here would be 2. So where on the y-axis do you see the number 2 at? Right there. Let's go ahead and take a straight edge, something, a ruler. Your ID card would work. And let's go ahead and draw a line connecting those two. Another way to kind of create more and more points would be to kind of create that pattern that you see here, the spacing between those two dots, and kind of just making more points to make sure your line is just that much straighter. All right, with that being said, let's go ahead and find now our x and y intercepts for the second equation. So again, I'm going to put my x part, 3x, equals the answer part, which is not negative 2y, it's negative 12. And 3 times what gets you negative 12? Or what's the opposite of multiplying by 3? Dividing by 3. So that's going to cancel out, because 3 divided by 3 is just 1. And what's negative 12 divided by 3? Negative 4. All right, so again, I'll write down my y-intercept of negative 4, I'm sorry, my x-intercept of negative 4. So where on the x-axis is negative 4 at? Oh, it's right there. And then our y part, negative 2y equals negative 12. All right, again, think about negative 2 times what gets you negative 12, or what's the opposite of multiplying? Dividing. So we'll divide both sides by negative 2. That will cancel out to be 1. And what would negative 12 divided by negative 2 be? 6. So we have a y-intercept of 6. So where on the y-axis is 6? All right. So we're going to draw a line, and you notice that they do cross. These two lines do cross at a point. In this case, that point right there. And that would be about negative 2 and positive 3. So negative 2 and positive 3, even though it's not written, as our coordinates for a point of intersection. All right, on the next one it says solve this system of equations by graphing. So here you see we have an equation. I'm going to kind of do this one a little bit differently. You'll notice because y is by itself on one side of the equal sign. So first I'm going to start with my y-intercept of 8. So on my y-axis, where is 8 at? Found it? Put a dot on it, just like you see here. All right, whereas this number to the left of x is our slope. We can write any whole number, as I see 2 as a whole number, by writing a 1 underneath it. All right, and if 2 is positive, will we go up or down? Up. And 1 is positive, will we go towards the negative side, which is on the left, or positive side, which is on the right? To the right. All right, so we'll go up 2 and over 1 and make a dot. We can also follow the same pattern going backwards. Down 2 and to the left 1, down 2 and the left 1, and draw our line. Okay. We'll do the second equation. And for this one, let's actually get y by itself. So I'll draw a line down the equal sign. What's the opposite of a negative x? Positive x. So let's add x to both sides, and that's y equals. Now a lot of students want to put this together, but we're going to keep them separate. We're going to put the x part first and the positive 6 part second. So on the y-axis, where is 6 on the y-axis? It's going to be right there. That's our y-intercept. Now for our slope, you notice that there is only one x, so I'm going to kind of write a 1 in there. And our slope is 1. Since our 1 is positive, will we go up or down? Up. And we'll go to the right 1. So from here, we'll go up 1 and over 1. Up 1 and over 1. And notice you can kind of continue this pattern over and over again, And you can go backwards. Down one into the left one. Down one into the left one. Oh, I already see a point of intersection. And you'll notice that point of intersection is actually right here. -2, that's a very popular number today, and 4. All right, let's continue on. Now it says solve a special system. So that means they may cross or they may not cross. We will see what happens here. So here we have y equals -x minus 2. So again, we'll start with our y-intercept of -2. So where on the y-axis do you see -2 at? Right here, even though it's not numbered, -2 would be here. And if it helps, what I would do before we continue on is just kind of number the numbers that are unseen. All right. All right. Ooh, that's supposed to be a -5. Hopefully that shines through. As you can see here, we do have a negative, 1 negative to be precise. So our slope is going to be -1. Will we go up or down? In this case, down because it's negative. And to the right 1. So we'll go down 1 and over to the right 1. And kind of continuing this pattern over and over again. You can make more dots if you'd like, but you can also draw your line straight through. The next thing we're going to do is we're going to take our second equation and we're going to make y by itself. So I noticed that y's got some other things next to it. We're going to get rid of first that +2. What's the opposite of a +2? -2. So that's going to cancel out and we're left with x plus y equals, what's 0 take away 2? -2. All right, the next thing we're going to do is we're going to move, we could actually use our x and y intercepts. So we can have x equals -2 and y equals -2. That one's pretty easy. And we can plot our points there. So let's go ahead and do that. Where's -2 on the y and x axis? And that would be there. And oh, do you notice something? Hey, didn't we just draw over that exact same line? Yes, we did. That means that this is the same line essentially. And if that's the case, then that means that there are infinitely many solutions. So whenever you're drawing the exact same line, it's infinitely many solutions. All right, now going on to word problems. I'm going to highlight some important information that you see here. Video Club A charges $10 for membership, $4 for a movie rental, $15 for membership, and $3 for movie rental. So take a moment right now and go ahead and fill in the spots for your equations. All right. Hopefully you wrote the following numbers. And filling in for step 2. I know it feels like we're just copying the same thing over and over again, but feel free to go ahead and do that. The next thing we're going to do is we're going to use a graph to kind of see what cost would be the same for both videos. So here it's $10 to start, and we're going to continue to add 4 to fill in the rest of this table. $15 to start, and we'll add 3 for the rest of this table and see at what point they will be the same. And unpause. Hopefully you got the following numbers and you found them to both be at 30. So at about 5 movies, it'll be about $30. They both started at a different point here. It started at 10 and the second point was at 15. So we can draw our 2 lines. They do cross at that point. All right. We'll come back for the checkpoint and to help you with homework.